Okay, this is section 2.1, and we're going to learn how to find the slope of the tangent line to a graph at a given point. We're going to find the derivative using the limit process, and we're going to describe the x values at which something is differentiable. And we're going to talk about what all those words mean. Okay, you should have already watched the video lesson 2 or chapter 2, lesson number 1. And it's going to explain, it should have explained what the slope of the tangent line is and how they come up with this formula that we're going to be using pretty soon. Okay, so, and you also have these handouts. Okay, a function does not have a derivative, x equals c, and then the notation and definition of derivative. All right, so let's look at the first couple of things. First of all, there are lots of different ways to denote derivative. And anytime we hear the word derivative, we're always going to think of the rate of change of something. If I said, what is the rate of change of this line? Well, the rate of change of line is just its slope. Okay, so slope is the derivative, is the same thing as derivative. So there's 4 different ways you might see derivative written. This right here, this little triangle, means the change in y over the change in x. Well, that should sound familiar because back in geometry and algebra 1, you learned that the change in y's over the change in x's was your slope. So that makes sense. Another way you might see it written is dy over dx. When I read this, I would say the derivative of y with respect to x. That means x's will be my variables in my problem. Okay, sometimes you might see dy dt. That means t's will be my variables in the problem. Another way you might see it written is f prime of x. If I have f of x equals something and I have to find the derivative of it, this is the symbol for derivative of f. So f prime of x is how I would read that. And then if I have y equals something, the symbol for derivative would be y prime. Okay, the process of finding the derivative of a function is called differentiation. And then a function is differentiable at x if its derivative exists and is differentiable on an open interval. And we'll talk more about that later. But basically, if I say, is it differentiable, that means, does it have a derivative? Can you find the derivative? Okay, remember, derivative means the rate of change of something. And back in that first video that you watched, it talked about the rate of change of the tangent line and finding its slope. So it also showed you this formula that we're going to be using. Okay, and we use limits in order to find derivatives. In calculus, calculus is divided up into 2 major branches, derivatives and antiderivatives, or we call them integrals. So derivatives, we can only find derivatives because we use limits in order to do that. So if we didn't have limits, we wouldn't be able to do the rest of calculus. So first semester in calculus will be having derivatives involved. Second semester we'll do antiderivatives. All right, so we want to find the derivative of f of x equals 3x minus 1. So here's what that means. Okay, I'm going to find the limit as h approaches 0, and I'm going to use this x plus h right here, and I'm going to plug it into any x's I have. That's what this first part means. Minus f of x. F of x is just my original equation. All over h, and then I'm going to find the limit. So here's what it would look like. The limit as h approaches 0. Okay, now x plus h is going to go into this x. So I have 3 times x plus h minus 1. That's this first part. Minus f of x. And f of x is this whole 3x minus 1. Okay, so now I'm just going to do a lot of algebra to find the limit of this. I need to FOIL this out and kind of simplify it. The limit as h approaches 0, distribute your 3, minus 1, distribute your negative. So now, if you do it correctly, you have a lot of things that should start canceling. Okay, this 3x will cancel with this negative 3x. This negative 1 will cancel with this 1. So then I have the limit as h approaches 0 of 3h over h. These h's will cancel. And now I need to find the limit as h approaches 0 of 3. Okay, well, we learned in chapter 1, what is the limit as h approaches or anything approaches a constant? It is that constant. Do you remember why? 3 is just this horizontal line. What is the limit as x approaches 0 or h approaches 0? Well, it's approaching 3. Okay, another way you could look at it is, this is just a linear equation. It's a line with a slope of 3, right? It looks something, I don't know, it actually goes through the point -1. So if I said, what is the rate of change of this line? Well, the rate of change of the line is its slope. So it makes sense that we got 3 as our answer. Let's do another one. Example 2. Find the derivative f of x equals 3. Okay. Let's think about this before we do a lot of algebra to it. This is just that same problem we just had, similar. 3 is a horizontal line. Okay? So if I am finding the rate of change, because remember the derivative is the rate of change of this line. What is the rate of change of this line? Well, the rate of change of a horizontal line is, I don't know why that keeps coming up, is, oh, I don't know what it's doing now. Hang on. It's not letting me, hang on. Okay, let me see if it'll let me. All right, so the rate of change of that line is 0, so the derivative has to be 0. Remember, derivative, rate of change, or the slope. Okay, let's do another one. Find the derivative of y equals x cubed plus 2x. So remember, I'm going to use x plus h and plug it into each x first. So here's what I have. The limit as h approaches 0, x plus h quantity cubed plus 2 times x plus h, that's that first part, minus f of x. F of x is our original function, all over h. Now here's the deal. This right here is going to take a little work, okay? You have to FOIL that out. And over here to the side, I'm going to show you x plus h quantity cubed. That means x plus h, x plus h, x plus h. Okay, so if I just do this first part, when I FOIL that out, okay, when I FOIL that out, I'm going to get this. The limit as h approaches 0. That's going to give me x squared plus 2xh plus h squared when I FOIL that. Now I still have this left over, so that's going to be times x plus h. So this part right here is this. Plus, now I need to distribute my 2. 2x plus 2h, distribute your negative, minus x cubed minus 2x, all over h. So now we still have to multiply this out. The limit as h approaches 0, x squared times x, x cubed, x squared times h. So I'm basically distributing my x squared. So that's going to give me x squared h. Now distribute your 2xh. 2xh times x. That's 2x squared h. 2x squared times h. That's 2xh squared. So I took my 2xh, distributed it to the set of parentheses. Now I'm going to do my h squared. H squared times x. H squared x. H squared times h. H cubed. So I just rewrote all of this by distributing, multiplying everything out, and got this. I'm going to write down all of that other stuff I have left. And if we did it right, things will cancel out. So let's hope we didn't make any mistakes. All right, so let me change colors here so they don't all start running in together. So I have the limit as h approaches 0. Okay, here's a positive x cubed, here's a negative. I have x squared h and another x squared h. These are like terms. So that's going to give me 3x squared h's. These two right here. I'm going to cross those out so I know I've used them. I have xh squared. Do I have any other xh squareds? So here's one right here. Even though they're in different order, it doesn't matter. So I have 2 plus one of these. That's going to give me 3xh squareds. So now those are gone. Do I have any other like terms? Here's 2x and a negative 2x. Those will cancel. And then I have h cubed plus 2h all over h. Okay, so now I still can't use direct substitution because I still get 0, but I can factor out an h on top. So the limit as h approaches 0, factor out a top, and I get, factor out an h, 3x squared plus 3xh plus h squared plus 2 all over h. So I took a h out of all of those. Now I can cancel these h's, and now I can use direct substitution to find the limit as h approaches 0. So I have 3x squared plus 3 times x times 0. Remember, I'm plugging 0 in for all my h's, plus 2. So these are all 0. So my answer is 3x squared plus 2. So the derivative of that first, way up here, of x cubed plus 2x, the derivative is 3x squared plus 2. All right, example 4. Find the slope of the tangent line to the graph of the function at the given point. So when I'm supposed to find the slope of the tangent line at a given point, I'm going to use this first, okay? And then I'm going to plug my answer and plug my x value into my answer. All right, so let's look at this first. If I'm supposed to find the slope of the tangent line, okay, when it's a linear equation, what did we learn from before? The slope of the tangent line to that graph is that line's slope. Because if I'm finding the rate of change of something, I'm finding the slope. What is the slope of this line? -5. Okay, so if you know what the slope is, if it's a linear equation, its derivative or its rate of change or its slope is the number in front of your x, -5. So I don't have to do all this. That's my answer. Example 5. Find the slope of the tangent line. Okay, so is this the same thing? Is this a linear equation? I know it's linear because it doesn't have any x squareds or x cubes. Okay, so I could go through this whole process, but I know the rate of change of this line is 3/2. So that's the slope of the tangent line. Okay, now on this one, it's not linear, so I actually have to go through this process. All right, so the first thing I'm going to do is plug x plus h in this right here. So I'm going to say the limit as h approaches 0, x plus h quantity squared minus 9 minus my original function, x squared minus 9, all over h. The limit as h approaches 0, I'm going to FOIL this out. Remember, when you multiply that out, I get x squared plus 2xh plus h squared minus 9 minus x squared plus 9. I distributed my negative. Now hopefully if we did it right, some things are going to cancel. I have an x squared and a negative x squared. I have a negative 9 and a positive 9. So now I have the limit as h approaches 0 of 2xh plus h squared over h. I'm going to write it over here. The limit as h approaches 0, I can factor out an h and have 2x plus h left over h. So now these h's will cancel, and now I can use direct substitution. Okay, when I substitute 0 in for my h, I get 2x. Okay, now that is, okay, the slope of the tangent line, 2x. But they want to know what is the slope at this point. So once I find my answer, I'm going to take my x value, which is 2, and plug it in. So 2 times 2, the slope of the tangent line at that point is 4. Okay, and I think Theorem 2.1 in your book, if f is differentiable at x equals c, then f is continuous at x equals c. So what they're saying is, if you have a derivative at a point, then it has to be continuous at that point. Okay, so you might star this because we'll be talking about it again later, but if it has derivative at a certain point, then it has to be continuous at that point. All right, I believe your assignment, oh, it's not. I will write down your assignment. Oh, it is. Section 2.1, there's the numbers that you're going to do. Okay, make sure you follow the directions.